right, so in this video, I'm going to review how to identify the 5 different types of chemical reactions that we're going to look at in this class. So the first type here, you have 2 individual elements or molecules reacting together to form one product. And so that is going to be a synthesis reaction, because you are producing a product, you're synthesizing a product. Notice the next one below it is the exact opposite. You take one compound or one molecule and you break it up into 2 or even 3 different products. That is going to be a decomposition reaction. Okay? For the next one on the top right, notice I have element A going in and it kicks out B to form a new compound and to have B all by itself. So since it is replacing B, we call this a single replacement reaction. For the one below it, notice now instead of just one element going in and kicking out one, both sets of partners switch places. So since they are replacing each other, both are, we call it a double replacement reaction. Okay, and for the last type of reaction, I have what is called a hydrocarbon. It reacts with oxygen and it forms carbon dioxide and water. Okay? So whenever you see a hydrocarbon reacting with oxygen to form carbon dioxide and water, we know that that is going to be a combustion reaction. All right, so let's actually identify the reactions below. Okay? And I'm going to abbreviate all of these reactions in the interest of time. For number 1, C6H12 reacts with oxygen to form carbon dioxide and water. Okay, so I'm going to first identify this, and then I also note that this is not balanced yet, so we're going to get some practice balancing. Notice I have a hydrocarbon reacting with oxygen to form carbon dioxide and water. This is going to be a combustion reaction. Okay, now let's balance that reaction. So I've got 6 carbons on my reactant side, so I'm going to put a 6 in front of carbon dioxide. I've got 12 hydrogens on my reactant side, so I'm going to put a 6 in front of water. Now comes the tricky part, figuring out my oxygens. So I've got 12 oxygens from carbon dioxide, and I've got 6 oxygens from water, so that gives me a total of 18 oxygens. So how do I get 18 oxygens on my reactant side? Well, I can just put a 9 in front of oxygen, and that gives me 18, because 9 times 2 is 18. Okay, for the next one, lead is going to react with iron sulfate, and notice what's happening here is the lead is going in and it is kicking iron out. So since one element is replacing another element, this is going to be a single replacement reaction. Now I'm going to check my balancing. I've got 1 lead on my reactant side, 1 lead on my product side, 1 iron on my reactant side, 1 iron on my product side, 1 sulfate on my reactant side, and 1 sulfate on my product side. So I am actually already balanced. For the next problem, notice I've got calcium carbonate. It is breaking up into 2 individual products. So that is going to be a decomposition reaction. I'm going to check balancing really quickly. I've got 1 calcium, 1 calcium, 1 carbon, 1 carbon, and 3 oxygens. Notice I've got 1 oxygen from calcium oxide, 2 oxygens from carbon dioxide to give me a total of 3. So that one was already balanced as well. For number 4, notice I've got P4 reacting with O2 to produce P2O3. So I've got 2 different reactants combining together to form one product. So this is going to be a synthesis reaction, and I do need to balance this one. So I've got 4 phosphoruses here on my reactant side, 2 on my product side. So I've got to put a 2 in front here to make that 4. Now I've got 6 oxygens on my product side. So to make that 6 oxygens on my reactant side, I'm going to put a 3 in front, and I am now balanced.